Hello students, today we're going to learn section 1.6, Graphical Transformation. Transformation just means changing the location of an image. So this is what we learned in 1.3. This is what we call our quadratic, or they call it the squaring function. Whenever you have h and k in our quadratic function, h represents the horizontal shift. Think opposite, and I'll explain that to you a little later. K is your vertical shift. These shifts are from the parent image y equals x squared. So y equals x squared is your parent image. Some books call it the original image. And here is your shift. Again, in section 1.3, we went over absolute value images or functions. So this is the absolute value of x minus h plus k. Again, h is your horizontal shift, think opposite, and k is your vertical shift, and it's from the parent image y equals the absolute value of x. So what you're going to notice with the parent images is that these are the original images. So this does not have an h or an k, it is just y equals the absolute value of x, and here comes your shift with a horizontal shift and a vertical shift. Example 1, it says describe the transformation for y equals the absolute value of x minus 4. So if you notice, there is no other number inside the absolute value, so you will not have a horizontal shift. It's going to be 0. K is negative 4, so you will have a vertical shift of 4 units downward. Again, we discussed earlier in the top here and here that k represents a vertical shift, either going upward or downward. So if it's negative, it's going downward. If it's positive, it's going upward. All right. Next problem. We have y equals the absolute value of x plus 2 plus 5. So in this case, we have now a horizontal shift and a vertical shift. So we have an h. So this h is positive 2, but when you take it out, I said earlier, think opposite. So the opposite of a positive 2 is a negative 2, and our vertical, our k shift, stays the same at 5. So now there's a horizontal shift. Since this is negative, 2 units to the left, and vertical shift of 5 units upward. Since this is positive, it's upward. Since this is negative on the horizontal shift, it's to the left. All right. So let's show you a graph. Okay, so y equals the absolute value of x. Let's compare that to, put a number, absolute value. We'll do this one, x minus 4. So we said earlier that this absolute value function will move 4 units downward. So in blue is the parent function. So when we graph, here is our parent function in blue, and this is our shift. This went, the blue image went 4 units downward. So that's the transformation. And again, transformation means the change of location of an image. Okay, so let's take a look at the other one. Let's go y equals, let's clear this, and let's put this in. So we'll put x plus 2, right arrow to get outside of the absolute value, plus 5. So With this one, we discussed that there's a horizontal shift 2 units to the left and a vertical shift of 5 units upward. So compared to our parent function is in blue, and you're going to see this shift and move upward. So this graph shifted 2 units to the left and 5 units up. All right. So again, these are all transformations. All right. Another type of transformation is called a reflection. When you have the opposite of the function, it reflects across the x-axis. When you replace negative x with x, it's going to reflect across the y-axis. So here it says name the reflection. So the reflection in this problem would be, well, it's the opposite of this. So the opposite is it's going to reflect across the x-axis. So across the x-axis. And let's check it. So go to y equals, let's clear this, put our parent function, which is our quadratic, x squared, and then put negative x squared. So we said it's going to reflect, let's see, across the x-axis. So remember the x-axis runs horizontal. So when we graph, here's the x-axis. Here's our parent function in blue, and this is right here, that's negative x squared. So what it did was this parabola reflected across the x-axis. There's a reflection across the x-axis. Okay. Now let's take a look at the next problem. This is now y equals x squared minus 2x plus 1. Well, notice I'm replacing all the x's with negative x. So when that happens, we have y equals x squared plus 2x plus 1 when you simplify everything. So when we type that in the calculator, this is x squared plus 2x plus 1. So again, you're going to notice the parabola in blue, the original. So there's our parabola, and now it's going to reflect across the y-axis. Oh, sorry. I'm going to type this in and this in. Let's do that again. So y equals, I forgot to put minus 2x plus 1. Okay, so here. So in blue, that's our original function. And then look what it's going to do. Now it's going to reflect across the y-axis. So it's mirroring across the y-axis. So when negative x is replaced for x, it's going to reflect across the y-axis. All right. Next type of transformation is called a stretch and a shrink. Now in other books, they call it a compression. So other books, they call it a compression. A stretch and a shrink occurs when there's a factor of a constant with the leading coefficient. So for example, here's the constant times the function. If c, right here, is greater than 1, then what we call is a vertical stretch, and it's also called a horizontal shrink, and I'll give an explanation of that soon. If c is between -1 and 1, then there's a vertical shrink and a vertical stretch. All right, so let me show you on here. So we have y equals the absolute value of x. So look at this constant. This constant's more than 1. That means if it's more than 1, you're going to have a vertical stretch, or you can call it a horizontal shrink. So let's graph that. So absolute value x, and then absolute value, 4, I forgot the 4 outside, 4 times the absolute value of x. So in blue, the first graph, it's going to be our absolute value. What you're going to notice is there's going to be a vertical stretch or a horizontal shrink. It's the same behavior. So what that meant was, if this is the original absolute value, what it did, if you can imagine, it did a vertical stretch. It stretched out vertically. So this blue graph stretched out vertically, and at the same time, look how wide this was. It had a horizontal shrink. So the width is shorter, but look at the length. The length is longer. So this is what you call a vertical stretch, or you can call it a horizontal shrink. And again, in other books they use the word compression. All right, let's look at this. If you notice this number here, this number is between -1 and 1. So if that's the case, then it's going to be a vertical shrink and a horizontal stretch. So this is what's going to happen. Let's make that, put parentheses, 1 divided by 4, and put the absolute value symbol, x. So we're going to compare our parent image or function to our actual image. So in blue, that was our y equals the absolute value of x. So look what happened when you had 1/4 in front of the absolute value. It actually, the height or the vertical shrank. So this is what you call a vertical shrink and a horizontal stretch. Look how wide this graph went. This red graph went wider than the original. So that's what you call a horizontal stretch, and at the same time it's a vertical shrink. All right, that's it. Have a good day.